Okay, let us start with the collision. That is another part of the work, power and energy. But remember, if you know a center of mass concept, then collision is better to understand. So let us cover this also in rotational motion. But now, in this particular three lecture series, we have to cover a collision, mainly how to apply law of conservation of momentum and what is the coefficient of restitution and what are the collision types. Elastic collision, inelastic collision, perfectly yes, inelastic collision, that is nothing but also called plastic collision. So with some practical examples, let us try to understand what is exactly a collision is. And then we can solve subsequent examples and MCQs. Okay. Okay, let us try to understand concept of collision in simple sense. So not going in through detail of the collision and impact, let us understand this. See what happens here. This is a one body, this is another body. Means yes, there are two balls. And keep in mind, here you have to apply a law of conservation of momentum. So recalling a basic of law of conservation of momentum is that when yes, so just revise that basic and how to apply law of conservation of momentum here. See what happens. We know impulse momentum principle. What is the impulse momentum principle? Impulse momentum principle says us summation f into this time is equal to this mass final velocity minus initial velocity. Okay, this is known to you. If suppose the condition occurs like this summation f becomes 0. Means it is in yes, usual sense, this is nothing but what? Resultant equal to 0. If resultant equal to 0, means summation f equal to 0. So this equation becomes like this. This is m v minus u. And if you again explore this, so mu is equal to mv. So what is this? Mvu is equal to, mv is nothing but what? What is the product of mass and velocity? That is a momentum. Yes, that is a momentum. So these are the linear momentum. And this is, yes, initial momentum. It is called initial momentum. Initial momentum. Initial momentum is equal to a final momentum. Is equal to a final momentum. Okay, so initial momentum is equal to final momentum. It is nothing but a law of conservation of linear momentum. Yes, we know this principle, and you have to use this type of here in the type of collisions. See what happens here. There is a one ball moving with some velocity. This say u1. This is again another body. Let us assume moving in the yes towards each other. There are other possibility also. Both are moving in the same direction. Both are moving either left. Both are moving either right, or like this that we have taken in this example. So first body moving towards right here, and second body moving towards the left here. What happens? There is after some time there is a collision. This type of impact, that is another name for the collision, is impact. This impact or collision occurs. Actually, I will tell you what happens exactly here. So if both blocks come together, they initially deform up to their maximum deformation, and then again restore their original size and shape and get separated with the velocities, and those velocities are known as v1 and v2. So these are the velocities after impact. So see, this is a situation before impact. This is a situation before impact. Let us use word collision here. Before collision, this is what seen at collision, and this is after collision. Okay, this is after collision. So before collision, they are moving with some velocities u1 and u2. So collision occurs, means maximum deformation of the body, and again regaining their sizes. So this is yes, another restoration concept is there, but I am not going to detail in that. But during the center of mass, we can go in detail in that. Okay. So and after impact, see, after collision, they are moving with different velocities, and that is v1 and v2. So these velocities are nothing but called separation velocities, and remaining this u1 u2 are called approach velocities. So what happens if you apply this initial momentum is equal to final momentum for this condition, we get like this: m1 u1 m2 u2 is equal to m1 v1 plus m2 v2. So this is we have to apply a law of conservation momentum here. So remember, the limitations or necessity of this condition is there are two bodies and external force should be zero, means this resultant force will be zero. Whatever happens in between two bodies. So there is no any external interference, external forces, etc. So keep in mind that thing. So initial momentum becomes final momentum. This simple law of conservation of momentum we can apply. Okay, so therefore, see, these are practical examples. If this collision is there, because of collision this happens. Here also बघा ही टक्कर म्हणजे collision. सरळ सरळ काय बघा आता या दोघांचं collision इथं होत आहे with some velocities and all things. So these are some practical examples of collision. So let us read this. A collision is said to occur between two bodies either if they physically collide against each other, either they physically touch with each other, yes, imparting of forces and all that, and that is cancelled with each other, or if the path of the one is affected by the force exerted by the other. This is another thing of collision. But simply you remember, said to occur between the two bodies either they physically collide against each other. So mostly the problem will be on this particular part, collide against each other. बघा आता थोडंसं पुढे जाऊ आपण. आता हे जे दिसते तुम्हाला u1 u2, this situation is remain same, but what happens sometimes this separation of bodies is not possible. So at that condition what happens, this is another possibility, you can say. This is another possibility. This ball, okay, these both balls may be clocked together, become one body and moving with some common velocity, v common we can say. This is another possibility. So there are two possibilities. Initially bodies are moving with different velocities, u1 and u2. Impact occurs, collision occurs. So there are two possibilities. Possibility one is this, possibility two is this. So either they moving or separately with different velocities v1 and v2, or becomes one unite body. This is, you have to consider one unite body. Let us say m1 plus m2. The mass is addition. If suppose this has a mass m1, this suppose mass m2. So this total body becomes one body, v common. So practical example is what? If you suppose this, there is a wall, okay, there is a wall, and you want to this, yes, smooth and nail. बघा भिंतीत खेळा मारायचा आहे, nothing but. So this is a hammer. This is a hammer. Let us see, this is a hammer. So hammer coming with some velocity. Let's say u2. This u1 is 0 initially, there is no velocity, but what happens after? Yes, after hammering this, what happens? After hammering action, so this hammer and this nail goes with some common velocity inside of this wall. Okay, दोन्ही मिळून काय जातील? दोन्ही बॉडी एकच होईल आणि त्यांना एक कॉमन वेलॉसिटी मिळेल. And yes, with common velocity they enter into the particular wall. That is, if man jumps in the boat, so boat and man together moves. That is also example of this type of what you call it, this possibility. So the names are given to these possibilities. So such collision is either elastic collision. Okay, such collision is elastic or inelastic. Perfectly, this is yes, inelastic, elastic or inelastic collision. And name given to such collision is a plastic collision, or some author also say perfectly inelastic collision. This is a plastic collision. So you can differentiate these collisions by understanding the concept of coefficient of restitution. So we have to see that coefficient of restitution now. But remember, if bodies get separated after collision, so there is a elastic or inelastic collision. And if body clock together or become one body and moving with some common velocity, that is known as a plastic collision. Okay, so let us understand concept of coefficient of restitution. Okay, again recalling same concept. So this is moving with some velocity. Yes, this is having u1 velocity initially. This is having velocity u2. This is the impact impact stage, and after impact, suppose this body moving with velocity v1 and velocity v2. And remember, not necessary both bodies moving opposite to each other, but moving in the same direction. So v1 and v2 are velocities after impact. See, this coefficient of restitution measures the degree of restitution of collision. What is a restitution? See, restitution is a restoration. Restoration means what? If this body, let us say this body has a one body, this body has a two body. If one body, yes, collides with body 2, what happens here exactly? There is a maximum deformation occurs of each body 1 and 2. But after some instant, very less instant, they restore their original shape and sizes. And again moving with different velocity or either clock together. So this is depend upon which type of collision is there. What is like practically which type of collision is there. So this restoration is nothing but called restitution. So coefficient of restitution gives a measure of the degree of restitution collision. So this sounds not very clear. But remember, it is a ratio of magnitude of relative velocity of separation. So relative velocity of separation means this is v2 minus y1. v1 is called relative velocity of separation. And this u1 minus u2 is called relative velocity of approach. As the difference of velocity, that's why it is named relative velocity. So v2 minus v1 divided by u1 minus u2. This ratio gives us coefficient of restitution. Now it is 50% clear. But remember, coefficient of restitution is a number which shows how much kinetic energy is available after collision between two bodies. If this number is high, near to 1, what it shows, there is no loss, little loss in kinetic energy after collision. Means what? When this body 1 collides with body 2, there is an exchange of kinetic energy in between them. And if see the example of this particular floor, if this is a body, this is any body or ball having zero velocity here, but after striking it gains some velocity. After striking it gains some velocity, let us say v1 is the velocity after striking. So because of this velocity, what happens? This floor exerts a force in all things. So this goes upward. This goes upward. Have you observed that this after one bounce, the ball, generally not goes up to this height. So the reason is there is a loss in kinetic energy. Okay. So there is if loss is little, so it gains up to very near to this particular maximum height. Okay. If goes with some more velocity. So coefficient of restitution plays a role in this. If this coefficient of restitution is very high, so body able to gain this height near to its original height. If this gains the original height, then what happens? E equal to 1, which is not possible practically. It is okay, very ideal condition, that is called elastic collision, that is elastic collision. So when this coefficient of restitution is 1, the meaning is what? The meaning is what? v2 minus v1 is equal to u1 minus v2. Means relative velocity of separation, it becomes equal to relative velocity of approach. So that condition is called elastic collision. So this type of collision is named as elastic collision. Remember, elastic collision. Elastic collision. So in that condition, this body goes up to this height also. So second condition, if E is equal to in between 0 to 1, if suppose it is in between 0 to 1, so such collision is not a elastic collision. This collision is a inelastic collision. Inelastic collision. So this is an example of inelastic collision. So ball gains after one bounce, ball gains some height very little below the maximum height. And these are the most practical conditions where coefficient of restitution is either it is between 0 and 1. So greater than 0 and less than 1. So that's why this condition is more practical, and that is E is equal to 0 to 1. And when remember the possibility when coefficient of restitution is 0 here. When this is 0 means what happens? So V2 minus V1 is equal to, it is 0. So V2 is V1 and all things. So that velocity becomes one velocity, that is called a common velocity. So after this impact, after this type of collision, body clock together, two bodies becomes one unite body. So that total body moving with some common velocity, v common, and that is example of plastic collision. That is example of plastic collision. This is example of plastic collision. So after understanding the concept of coefficient of restitution, we can divide collision in three types: elastic, inelastic, and plastic. See, the difference is clear. When E equal to 1, ideal condition, elastic collision, total kinetic energy is exchanged. Total kinetic energy is converted into, yes, there is a no loss. We can say there is no loss in kinetic energy. When E is between 0 to 1, there is some loss in kinetic energy. And if loss is more, then height gain in this example is very less. And if this loss is very little, so this body able to gain a maximum height, very little maximum below the maximum height. And when this E is 0, then what happens? A plastic collision. So there is no meaning of this V1 and V2 there. The body clock together and moving with common velocity. That is called, yes, a plastic collision. So in this way, this is the significance of coefficient of restitution. So using this E equal to 1, E equal to 0 to 1, and E equal to 0, we can divide, yes, collision in three forms. Let us understand with some table also. Okay, see this table. What happens here? Elastic, inelastic, and plastic collision. So this plastic collision is also called perfectly inelastic collision, even though. So see about a kinetic energy. What is kinetic energy? Inelastic collision, this total kinetic energy is conserved. It means there is no loss in kinetic energy. Whatever initial kinetic energy present, that is totally converted into the final kinetic energy. So initial kinetic energy equal to final kinetic energy for this particular condition. So initial kinetic energy is equal to a final kinetic energy. In second case, inelastic, the coefficient of restitution is, yes, between the 0 to 1, there is kinetic energy is not conserved. It means there is a loss. There is a loss. So you can calculate this loss, initial kinetic energy minus final kinetic energy. And it, yes, in plastic collision, yes, there is also loss, not conserved. That is not conserved. So kinetic energy conserved only in elastic collision. In inelastic and plastic collision, kinetic energy is not conserved. There is a loss in kinetic energy. But remember, momentum is conserved everywhere, because as this is a, yes, there is no any external force acting on the system of the balls or bodies, etc. So that's why momentum is conserved everywhere. So initial momentum becomes always equal to final momentum. Anyway, so in first collision, you can write equation is like this. I'm just writing here for first m1 u1 plus m2 u2 is equal to m1 v1 plus, yes, m2 v2. And in second case, remember, it is also same equation becomes. Only velocities, yes, there is coefficient of restitution 1. So velocities are more, get the more values compared to the inelastic collision. But what happens in plastic collision? So see, the equation becomes m1 u1 plus m2 u2 is equal to, see, this is a change, the total mass and v common. So this is a change of plastic collision. So momentum is conserved, it's okay. So coefficient of restitution here is in elastic collision. Okay, in elastic collision here. So I'm sorry for this. So this is, forget about this. You know that now this is, yes, 1, 0 to 1, and it is 0. Okay, in plastic collision that was 0. But what happens after collision? After collision, body is moving with different velocities. After collision, body is moving with different velocities in elastic collision. And same story in elastic collision also. Body moving with different velocities, maybe in the same direction, maybe in the opposite direction. But in plastic collision, what happens? Body is moving together with common velocity. Okay, these are the observation after collision. Therefore, examples are collision between atomic particle is ideal, that is elastic collision. Collision between ordinary particle is practical, I have told you, inelastic collision. That is a practically happens. Collision between ordinary particles, because in for which coefficient of restitution is between 0 to 1. And plastic collision is example of nail and hammer or pile and hammer, or a man jumps into the boat and then boat and man becomes one body and moving with common velocity. These are the some practical examples of plastic collision. Okay, so this is the difference between these collisions. So let us understand with the, with the coefficient of restitution, remember. So as per the coefficient of restitution, you can divide collision is either elastic or inelastic, or it is a plastic. Okay, let us take some practical examples or some numericals or some examples on this type of collision. See, first type of collision is, that is suppose elastic collision. So here velocities are suppose like this u1 and this is u2. Remember, the first thing is that the velocities are opposite to each other. So that's why you have to apply a proper sign conventions while applying a law of conservation of momentum. Okay, just applying a law of conservation of momentum for this. That is initial momentum E is equal to a final momentum. So initial momentum is m1 u1 plus. So this direction is taking plus, this direction taking negative. Okay, right direction positive, left direction negative. So this becomes m2 minus u2 is equal to m1 v1 plus m2 v2. So this gives a law of conservation of momentum equation to solve a particular numericals. And second thing is that coefficient of restitution is given by v2 minus v1 divided by u1 minus u2. Remember, in this case E is equal to 1. E is equal to 1. So that's why this equation becomes v2 minus v1 is equal to u1 minus u2. After putting a value of mass, this make equation number 1 and this equation number 2. And if you solve these two equations, yes, you can calculate velocities v1 and v2 after impact. So this is how to apply law of conservation of momentum for this situation. If suppose collision is inelastic, it means E is in between, you know that E is in between 0 to 1. Let us say this is 0.6. So in that case, same story, initial momentum becomes equal to a final momentum. So m1, let us say this example, u1 is moving in this direction, u2 is also moving in this direction, same direction. So in that case, m1 u1 plus m2 u2 is equal to, I am not taking a negative sign here, remember, because direction opposite is, yes, vector, these are the vectors. As we are dealing with the vectors, we have to be very careful about the sign conventions. So that is why m1 v1 plus, yes, m2 v2, m2 v2. So if you remember, after solving these two equations, this equation number 1 is already there. So coefficient of restitution is v2 minus v1 divided by u1 minus u2, and this is a 0.6. So 0.6 into u1 minus u2 is equal to v2 minus v1. So this is equation number 2. If you solve these two equations, these two simultaneous equation, we get a v2 and v1 here. So why I am taking this? So this is, see the difference, E equal to 1 you have to put, E is 0.6 there. And remember, here is no loss of kinetic energy. Means here, whatever kinetic energy Ke1 is becomes here Ke2. But in this case there is a loss. Ke1 is greater than Ke2. So this is a difference between these two collisions. Now moving towards plastic collision. See a practical example. Suppose this is a pile and we want to move this pile or press this pile into the soil. This is a soil. Okay, so if you apply force from the hammer on this particular portion of the pile, this goes. So this scene is here. This scene is here. But what happens? Initially there is no velocity for pile. It is 0 because it is only placed at the, yes, it is only hold at the place. And then hammer is, yes, hammer presses it, hammer apply the force at this point. But hammer has some velocity because it is coming from this particular height h. So that hammer is always root 2gh. Considering downward motion under gravity, uh is root 2gh. So if you apply here, so it goes with the common velocity. So now these two body becomes one body. Means here total mass is mh plus m pile you can take. In this case, how to apply law of conservation of momentum? Again same, initial momentum E is equal to a final momentum. So mass of hammer, velocity of hammer, mass of pile, velocity of pile, and lastly mass of hammer plus mass of pile, as they become, yes, unite body, into velocity common velocity. So this common velocity, yes, this common velocity we can calculate using this law of conservation of momentum. So there is no need of the second equation here because there is only one unknown you have to calculate. As here E is 0, so there is no question about using a relation or using this formula V2 upon V1. As E is 0 there, so there is no meaning of this. So VC we can calculate here. So this is a slight difference between these elastic, inelastic and plastic collision and how to deal them. So plastic collision has number of example again. So I have told you this is atomic, this is ideal, this for ordinary particles, and this is for, yes, pile and hammer or boat with man. The man jumps in the boat and boat man with together come one body and moving with some common velocity. So that is the example of plastic collision. If you, yes, if you place a nail on the wall also, that is also the example of plastic collision. Whenever after impact bodies becomes unite and moving with common velocity are all examples of plastic collision because there is a permanently deformation of the bodies. Body doesn't regain their original size and shape. They become one, they become unite, they become single body. So that is nothing but a plastic collision. But in elastic collision and elastic collision, velocities are velocities are separated and moving with different velocities we can say. But the slight difference is that in elastic collision, total kinetic energy is exchanged with the other body, but in elastic collision, kinetic energy is not exchanged with the other body. There is some loss in kinetic energy. So this differentiate in elastic collision from the elastic collision. See, value of the coefficient of restriction is always a 1. Maximum it is 1. The greater than 1 is meaning is what? Total whatever kinetic energy is you applied initially, that is totally exchanged into, yes, to another body. So this is not possible. Yes, if it is possible, that is a name given to that supersonic elastic collision. But forget about that. Our requirement is what? 0 to 1. If it is 0, plastic collision. If it is 0 to 1, inelastic collision. If it is 1, elastic collision. So this is sufficient for particular this portion. Okay. So let us conclude this lecture and solve some examples and subsequent MCQs.